In this video, I am going to explain the universal law of gravitation, because it states that the force of attraction between the two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance in between them. So you can say that, so we can say that F is directly proportional to, if you combine these two, we can say that F is directly proportional to m into n, m into m, when m is the two masses, m and divided by d square. Just I will show you this on the board, on the palette card I will show you. So here, or you can say that F is equal to g, where g is a constant of proportionality, and it is known as universal gravitational constant, whose value is 6.673 into 10 to the power minus 11 Newton meter square per kg square. It's okay. So this I am showing you in a palette card. You see here, just you watch it, please. See, this is here. See, in the figure, A and B are the two masses. A and B are two masses. And mass of A is capital M and the mass of B is small m, and therefore the force of attraction between these two is proportional to m into m, capital M into small m. Right? It is just, you can see in the in this palette card, you can see here now, and the force, and you can see the distance between these two objects is d, it is d, and therefore the force of attraction between these two objects is inversely proportional to d square. And if we combine these two together, just you can see here now, after combination, F is directly proportional to m into m divided by d square. There is a proportional sign. So if we equate this equation, then we will have to give one constant. So here the g is the constant. Constant it is here. It is the constant of proportionality, and it is called universal gravitational constant. And the value of g is 6.673 into 10 to the power minus 11 Newton meter square per kg square it is. See? So just you can see in this paragraph, it's all been explained here like this, it is here. So in the end you get this one. So this is the force of attraction between the two bodies, can be calculated using this formula. The value of g is 6.673 into 10 to the power minus 11 Newton meter square per kg square it is. Look at it is capital G, and this is known as universal gravitational constant, and this is known as universal gravitational constant, it is known as. So in order to calculate the force of attraction between these two bodies, and let me tell you now, it was Henry Cavendish. It was Henry Cavendish who had found out the value of capital G by using a very sensitive valence, and this value was accepted. And this is equal to 6.673 into 10 to the power minus 11 Newton meter square per kg square it is. It's okay. And so we do have here now, okay, it's just you can see that now we can have these 5 variables are there, 5 variables. So if the 4 are available, we can find the 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 last 5 variables. We can find the value of last 5 variables, we can find it is here. And there's one inverse square law. Okay, inverse square law, it states that if is inversely, if is means force per action is inversely proportional to the square of the distance between the two objects. Okay, and if the value of d gets bigger by a factor of 6, then it becomes the force of attraction decreases by a factor of 1 by 36 times, okay, smaller. So okay, because the force of attraction is inversely proportional to the square of the distance between them. So if d is small, f will be big, and if d is big, then f will be small. It's okay. So inverse square law is this, means the force of attraction is inversely proportional to the distance, square of the distance in between the two bodies. So this is. Now what is the importance of universal law? Okay, universal law of gravitation has a lot of importance. It is here. If it had not been there, then I think we do not have an atmosphere surrounding the earth. The atmosphere or the air would have gone far away, anywhere in the universe. So it is holding all the things together. It is here. It is holding all the things to the earth. The force of gravitation of the earth is holding everything towards the earth. Is here. It is holding us also. It is also moving the moon around. The earth is moving the moon around it. This is also due to the force of this gravitation between the earth and the moon. And all the motion of the planets in the universe is because of this universal gravitational force. It is and this tides and tides in the oceans are also called due to the moon and the sun, the force of attraction between the moon and the sun. So it's like this. So universal law of gravitation has very much importance. It has very much importance, isn't it here? So it is a force which binds everything to the earth. It is okay. Now let me tell you what is free fall. Whenever an object falls under the force of gravity alone, that is called a free fall. And if something falls from very high, the velocity of that object goes on increasing till it touches the earth. It is and here the earth attracts everything towards its center, everything towards the center. So whenever an object falls, the force of gravity of the earth makes the object falls changing each and every fraction of second its velocity. So its velocity changes, and the change in the velocity is known as acceleration. So whenever a body is in free fall, it has acceleration. So its acceleration goes on increasing, and that is why it is very difficult to hold a cricket ball which is coming down from a very high up, very high up in the sky. It's okay. So it is very difficult to hold the ball coming from very high up in the sky. So because its acceleration is very much here, and the acceleration speed up the velocity. So the velocity of the ball is very much Okay, when it falls to a very high distance. Okay, high distance. Okay, next it is to find the acceleration of the earth, or acceleration of any planet we can find out, okay, using some formula is there. So this I will tell you in other class. Okay, till this you enjoy it, you go through this one. I think it will be very helpful to you. uh, Thank you very much. Okay, all right.